Hey guys, I'm be doing the introduction to antivirus. So we're going to be understanding how antivirus software works and what detection techniques are used to bypass malicious file checks. Task 1, Introduction. Welcome to Intro to AV. Antivirus, AV software is one of the essential host-based security solutions available to detect and prevent malware attacks within the end user's machine. AV software consists of different modules, features, and detection techniques, which are discussed in this room. As a red teamer or penetration tester, it is essential to be familiar with and understand how AV software and its detection techniques work. Once this knowledge is acquired, it will be easier to work towards AV evasion techniques. Learning objectives. What is antivirus software? Antivirus detection approaches, enumeration, installing AV software in a target machine, test in a simulated environment. Room prereqs. General knowledge of host-based detection solutions. Check the lay of the land room for more information. General experience with hashing crypto. Check the hashing crypto 101 room for more information. Basic knowledge of YARI rules. Check the THM YARI rules room for more information. Let's get started. Complete. Task 2, Antivirus software. What is AV software? Antivirus, AV software, is an extra layer of security that aims to detect and prevent the execution and spread of malicious files in a target operating system. It is a host-based application that runs in real time in the background to monitor and check the current and newly downloaded files. The AV software inspects and decides whether the files are malicious using different techniques, which will be covered later in this room. Interestingly, the first antivirus software designed solely to detect and remove computer virus, nowadays that has changed. Modern antivirus applications can detect and remove computer viruses as well as other harmful files and threats. What does AV software look for? Traditionally, AV software looks for malware with predefined malicious patterns or signatures. Malware is harmful software whose primary goal is to cause damage to a target machine, including but not limited to gain full access to the target machine, steal sensitive information such as passwords, encrypt files and cause damage to files, inject other malicious software or unwanted advertisements, use the compromised machine to perform further attacks such as botnet attacks. AV versus other security products. In addition to AV software, other host-based security solutions provide real-time protection to endpoint devices. Endpoint detection and response, EDR, is a security solution that provides real-time protection based on behavioral analytics. An antivirus application performs scanning, detection, and removing malicious files. On the other hand, EDR monitors various security checks in the target machine, including file activity, memory, network connections, Windows registry, processes, etc. Modern antivirus products are implemented to integrate the traditional antivirus features and other advanced functionalities, similar to EDR functionalities, into one of the products to provide comprehensive protection against digital threats. For more information about host-based security solutions, we suggest visiting the THM Lay of the Land. AV software in the past and present. McAfee Associates, Inc. started the first AV software implemented in 1987. It was called VirusScan. Its main goal at the time was to remove virus named Brain that infected John McAfee's computer. Later, other companies joined in the battle against viruses. AV software was called scanners, and they were command line software that searched for malicious patterns in files. Since then, things have changed. AV software nowadays uses the graphical user interface to perform scan for malicious files and other tasks. Malware programs have also expanded in scope and now target victims on Windows and other operating systems. Modern AV software supports most devices and platforms, including Windows, Linux, macOS, Android, and iOS. modern AV software has improved and become more intelligent and sophisticated as they pack a bundle of features including antivirus, anti-exploit, firewall, encryption tools, etc. We will be discovering some AV features in the next task. What was the virus name that infected John McAfee's PC? All right, so they mentioned that here is brain. So grab that, put it in here. What PC antivirus vendor implemented the first AV software on the market? That would be McAfee. Antivirus software is blank based on security loop solution. Is a antivirus software is a blank base security solution. This one might take me a second to. Okay, I had to control F it because it looks like they're looking for a specific word, so I found host-based application. All right, we're in. So that's all of that. Let's move on to task 3, antivirus features. Antivirus engines. An AV engine is responsible for finding and removing malicious file code and files. Good AV software implements an effective and solid AV core that accurately and quickly analyzes malicious files. Also should handle and support various file types, including archive files, where it can self-extract and inspect all compromised files. Most AV products share the same common features, but are implemented differently, including but not limited to scanners, detection techniques, compressors, and archives, unpackers, emulators, scanners. The scanner feature is included in most AV products. AV software runs and scan in real time or demands. The feature is available in GUI or through the command prompt. The user can use it whenever required to check files or directories. The scanning feature must support the most known malicious files to detect and remove the threats. In addition, it also may support other types of scanning depending on the AV software, including vulnerabilities, emails, Windows memory, and registry. Detection techniques. An AV detection technique searches for and detects malicious files. Different detection techniques can be used within the AV engine, including signature-based detection is a traditional AV technique that looks for predefined malicious patterns and signatures within files. Heuristics detection is more advanced technique that includes various behavioral methods to analyze suspicious files. Dynamic detection is the technique that includes monitoring the system call and APIs and testing and analyzing in an isolated environment. We will cover these techniques in the next task. A good AV engine is accurate and quickly detects malicious files. A fewer false positive result. We will show several AV products that provide inaccurate results and misclassify a file. Compressor and archives. The compressor and archives feature should be included in any AV software. It must support and be able to deal with various system files types, including compressed or archive files, zip, TGS, 7-zip, ZAR, RAR, etc. Malicious code often tries to evade host-based security solutions by hiding compressed files. For this reason, AV software must decompress and scan through all files before a user opens a file within the archive. PE, portable execution, parsing, and unpackers. Malware hides and packs its malicious code by compressing and encrypting it within a payload. It decompresses and decrypts itself during runtime to make it harder to perform system static analysis. Thus, AV software must be able to detect and unpack most of the known packers, UPX, ASPack, etc., before the runtime for static analysis. Malware developers use various techniques, such as packing to shrink the size and change the malicious file structure. Packing compresses the original executable file to make it hard to analyze. Therefore, AV software must have an unpacker feature to unpack protected and compressed executable files into the original code. Another feature that AV software must have is the Windows Portable Executable PE header parser. Parsing PE of executable file helps to distinguish malicious and legitimate software.exe files. The PE file format in Windows 32 and 64-bit contains various information and resources, such as object code, DLLs, icon files, font files, and core dumps. Emulators. An emulator is an antivirus feature that does further analysis on suspicious files. Once an emulator receives a request, the emulator runs the suspected exe, DLL, PDF, etc. file in a virtualized and controlled environment. It monitors the executable file's behavior during the execution, including the Windows API calls, registry, and other Windows files. The following are examples of the artifacts that the emulator may collect: API calls, memory dumps, file system modifications, log events, running processes, web request. An emulator stops the execution of a file when enough artifacts are collected to detect malware. Other common features. The following are some common features found in AV products: a self-protection driver to guard against malware attacking the actual AV, firewall and network inspection functionality, command line and graphical interface tools, a daemon or service, a management console. Which AV feature analyzes malware in a safe and isolated environment? I would say it's emulator. Probably not with an S, but we'll check it out. All right, that works. And blank feature is a process of restoring or decrypting the compressed executable file in the original. All right, so that would be an unpacker, I believe, because they mentioned it here. Unpack of protected and compressed executable files. Read the above to proceed to the next task, where we'll discuss the AV detection techniques. All right, great. Click on that, and we're done with task 3. Over to task 4, deploy the VM. We have provided the Windows 10 Machine Pro to complete this room. The AV can be accessed through the in-browser feature once the VM is deployed. Your browser should split into 2 windows as followed. You have 2 windows here. If the browser doesn't split, then you could put the split view. You can also connect via RDP. Make sure you deploy the attack box or connect to the VPN and use the following credentials. Okay. So I prefer to use my own attack box. If you'd like to use their in-browser one, you can do it by just starting the machine and then also click to start the attack box so you can utilize that. Otherwise, you can use your own, and they show you how to install xfreerdp and get connected to their VPN if you follow their instructions by clicking the help. Now, do know I have a video on that, and you could definitely look at the video I have where I show you how to set up your own attack box. Highly recommend you watch it. I'll just pause it real quick so I could get everything set up. Okay, and I've gotten connected to the TRYHACKME network via the OpenVPN. I am now gonna just paste in the command they have there for the xfreerdp and see if it works. Oh, another thing is whenever you use this, you have to sudo. So I notice it does not work unless you sudo this. Oh, and of course you have to start your machine, which I failed to do, which is why I didn't work. Personally, I know they use free xfreerdp. I prefer to use Ramina. It's just a lot better for me. I could control how wide the screen is, and it's easier for me to use. Although I do have xfreerdp set up as well. So I'll just give this a second for it to load, and we'll take a peek at the next task. I'm also gonna click complete there and give that a second to load. So we have task 5, AV static detection, other detection techniques, AV testing, and fingerprinting. Conclusion. And it looks like this is a free room, and I really like free rooms because it allows anyone who doesn't want to pay for a TRYHACKME subscription to do it. And I think this is great that they offer this. So I have the IP address here. I'm just going to copy it. And if I wanted to, what I can do is just hit the upward arrow, and I'm going to show you how to get connected with this command once you have your attack box set up and you've connected to their VPN. I have plenty of videos showing you how to do that. If you're interested, you could definitely take a look at those. I'm just going to put in the IP address there for this, where it says machine IP, and then I'm going to click enter. And it should show a screen in a second. Move this a little bit over here. See if it comes up. Oh, looks like you ran into an error, failed to connect. Okay, right. Well, I'm gonna give this a second shot here. So I'm gonna try Ramina instead. For some reason that did not take. So let's go over here. If I'm having issues over here, it might be a bigger issue. So here we go. And let me just make sure that my session is good here as well. Yeah, initialization complete. Lost connection. Okay, so this is a little odd. I'm gonna try pinging that IP and see if I get a connectivity. If I don't, then we may have some issues. And it looks like I'm not getting a reply back. So let me move over here and see what might be happening here. Oh, I see. Okay, let me grab this command here. Maybe I'll give it another shot. Looks like that's still not working. Alrighty. I'm just going to open up a new terminal, paste that in, put the sudo command in front. Check my IPs here, make sure they are good. Because that first one, obviously I didn't have the IP, now I have the IP. Yep, that IP looks good to me. Enter, put in my password, I'll pause that. All right, looking better. After I put my password, it's asking, do I trust the above certificate? Yes, I do. And I'll give this a sec, and it looks like it's going through. Perfect. All right, well, since I have this open, I guess we'll do it this way. I'm pretty sure Amina would have started working. Maybe just a glitch in the matrix. This happens. All right, so we're good to move on to task 5. Let's do this. Let me take a glance at it, see how much reading we have going on here. Okay, quite a bit of reading. All right. So, AV static detection. Generally speaking, AV detection can be classified into 3 approaches. First, static detection, second, dynamic detection, and third, heuristic and behavioral detection. Static detection. Static detection technique is the simplest type of antivirus detection, which is based on a predefined signature of malicious files. Simply, it uses pattern matching techniques in the detection, such as finding a unique string, CRC checksum sequence of bytecode, hex values, and cryptographic hashes, MD5, SHA-1, etc. It then performs a set of comparisons between existing files within the operating system and database signatures. If the signatures exist in the database, then it is considered malicious. This method is effective against static malware. And we have a little diagram here. In this test, we'll be using a signature-based detection method to see how antivirus products detect malicious files. It is important to note that this technique works against known malicious files only, with pre-generated signatures in the database. Thus, the database needs to be updated from time to time. We will use the XfreerdP antivirus software to demonstrate how signature-based detection identifies malicious files. The XfreerdP software is pre-installed in the provided VM, and we can access it in the following path. In the program files, and it looks like it's in a location. We will also scan a couple of malware samples, which can be found on the desktop. The malware sample folder contains the following files. 1. EIC_car is a test file containing an ASCII string used to test AV software effectiveness instead of real-time malware that could damage your machine. For more information, you can visit the official EIC_car website. 2. Backdoor is a C# program that uses a well-known technique to establish a reverse connection, including creating a process and executing Metasploit framework shellcode. 3. Backdoor 2 is a C# program that uses process injection and encryption to establish a reverse connection, including injecting a Metasploit shellcode into an existing and running process. 4. AVCheck is a C# program that emulates AV software in a target machine. Note that this file is not malicious, and we will discuss this tool in more detail in task 6. And 5, notes.txt is a text file that contains a command line. Note that this file is not malicious. Okay. XfreerdP comes with its database, and during the installation, we need to download and recently updated version. Let's try to scan the malware sample folder using the clam.exe binary and check how clam performs against these samples. All right, so I will just do what they're doing here. I like the split screen view, but I also prefer having a lot of room. So what we'll do is I'll just kind of move this up here, and we'll be able to see the commands. And down here, or what we can do is we can just move this over here. Move this over here. There's a lot of free real estate over here, so we'll just move this this way, and then just move this over here, so we just get like a little view right there. Okay, good. Everything's coming into picture. We got this over here. We'll just expand this out a little bit more, so you can see the full desktop there, and hopefully that displays well on your screen. Maybe move this a little bit further in so it's not, so it displays very well. Okay, good. I'm gonna type cmd here, and I'm going to run as administrator. Okay, and you can see they provided me the path to it, so I'm just gonna copy this, and if you're using their machine, you have to make sure you copy it to the clipboard. And I'm just going to run this. And if you're kind of interested in what this looks like, where are these files, how is this happening, this PC, C drives, program files, x86, then they got the, or maybe they don't, maybe this is just an example, and I guess it was a good idea to just check to make sure it's actually here, which I don't see it. Oh, program files, okay, so it's regular program files, and clam.exe, there it is, okay, good. And then they've got the executable here for this program here. And if I go to view, hidden file extension, we can see this is the exe here. And we're going to run that exe against this sample, which we have on the desktop, which is like right there, as you can see. It's one of these samples. It looks like it might be that one. So, or actually there's a sample folder here. Okay, so I'm guessing we're just running it against all of this. They've just mentioned AV checker exe, backdoor 1, backdoor 2, and all of that. So let's go ahead and just run this command here. I'm just going to paste it in, just copy paste it and press enter. The above output shows the Clam AV software correctly analyzing the flag 2 of our test files, the EICAR, backdoor, AV check, and note text as malicious. However, it incorrectly identified the backdoor 2 as non-malicious. Well, it does. This can run the clam.exe debug file to scan, and you'll see all modules loaded and used during the scanning. For example, and I guess we'll do that next because looks like I want to run that command to see what it looks like. But here we can see the antivirus database is older than 7 days, so it's not exactly, I guess, up to date. Please update as soon as possible, but it's still loading these files. And if you're completely new to this, maybe I could consult with you here. So you have these files and you're essentially running them against a static signature file database, and it's going to compare the hashes of, or the checksums of malware to the checksums of these files. And if they match, then it will determine that the file is malicious. If they don't match, then it will determine that the file is not malicious. So I guess if I could compare this to anything, it's kind of like if you have a police officer and he's got a booklet full of people's pictures, and he has people's pictures who are criminals, and he were to compare these people as they walk past him, and if he saw in their picture in that picture book, he would know they're malicious, they're a criminal, and then he would handcuff them and put them in jail. That's kind of what's going on here. And we can see here we have our results. So this one's okay. This one says found, so backdoor 1 just triggered something. Found, that triggered something, and then this other file that says okay is it's gotten past this security there, I guess you could say. So that's pretty great, and that's exactly what they got as well here for their test results. All right, so let's go into this next one. You can run the clam.exe debugging file to scan, and you can see all the modules loaded and used during the scanning. For example, it uses the unpacking method to split the files and look for predefined malicious sequences of bytecode values. And that is how it is able to detect the C# backdoor. The bytecode value of the Metasploit shellcode used in the backdoor 1 was previously identified and added to Clam AV database. However, backdoor 2 uses an encryption technique, XORing, for the Metasploit shellcode. That's why it wasn't, or actually it was detected, that one, wasn't it? Backdoor 2 actually was not detected, never mind. For Metasploit shellcode, resulting in a different sequence of bytecode values that it did not find in the Clam database. So that one got passed. However, backdoor 2 uses an encryption technique, so that's why it got past it. So while the Clam AV was able to detect the EICAR.com test, which is EICAR, and it was able to detect that as malicious using the MD5 signature based technique to confirm this, we can rescan eicar.com test file again in debugging. At some point in the output, you should see the following message. Okay, so let's why don't we do that and see what happens. So we have our first command here, and it ran it against the samples. Perhaps we don't want to run it against all the samples. We just want to run it against that specific file. I'll just click the up key on my keyboard, the arrow pointing up, and then I will see that I am only trying to scan this eicar.com file. So what I can do is just type that in here. Right, eicar.com, and specify debugging before that. So we'll just go up here in the front for the file -- debug space. And let me expand this out so you can see the full thing. And we'll run it and see what we get here. See, it's running a debug mode. It's giving us a bit more information similar to like verbose and some of the other programs you worked with. All right. And at some point we should see this within the matrix output here. Now let's generate the MD5 value of the eicar.com. If it matches what we see in the previous message from the output, we will be using the sig tool for that. Okay, all right, great. Why don't we do that? So to generate that output, looks like we need to just copy this command here and just paste that in. And we can see it's generated this hash right here. And we're going to be using that for the next tool. Create your own signature database. One of CLAM AV features is creating your own database, allowing you to include items not found in the official CLAM AV database. Let's try to create a signature for backdoor 2, which CLAM AV already missed, and add it to the database. The following are the required steps. 1, generate an MD5 signature for the file. 2, add the generated signature into the database with the extension .hdb. And 3, rescan the CLAM AV file against the file using our new database. First, we'll use the sig tool, which is included in CLAM AV suite, to generate an MD5 hash of backdoor2.exe using the MD5 argument. All right, so let's generate that hash for MD5 backdoor 2. And I'm just going to grab the code that I need here, the command, and just put it here and see if it works off the bat or if I need to make any adjustments to it. Oh, copy. There we go. All right, so it says no file directory. So reason being is because I have to navigate to the location of this file. Looking at this command, it looks like they have navigated to it. So I could easily navigate to this as well. I'll just copy this path here. I'm going to type change directory cd and then the path of the file that I want to go to. And then now I'm in that location. So now I should be able to run this command. And press enter. And then I've generated the hash for backdoor2.exe. As shown in the output, the generated hash string contains the following structure: hash, size in bytes, file name. Note that CLAM AV uses a generated value in the comparison during the scan. And now that we have the MD5 hash, now let's create our own database. We'll use the sig tool and save the output in the file using the arrow THM.hdb as followed. So looks like we're in the directory we need to be in. We're just going to copy this command here, and we're just going to and put this here. And it looks like it might take the MD5 hash. I'm not sure if we have to put the MD5 hash here where it says MD5, but we'll see if it errors out for us, because I haven't done this before. Yep, that seemed to work, but I have worked in the command line before. So as a result, the THM HDB file will be created in the current directory that executes the command. We know now that ClamAV did not detect the backdoor 2 using the official database. Now let's rescan it using the database recreated and see the results. All right, so now that we've added that to our database, we're going to now just run another scan, and I'm gonna just type that command in there, more like paste it. And we can see that it's now got a, let's see, as we expected, the ClamAV tool flagged the backdoor2.exe. Yep, backdoor2.exe. Let's go down a little bit, see if it gave us any more information here. Binary as malicious based on the database we provided. As practice, added the avcheck.exe MD5 signature into the same database we already created, then check whether the claim AV can flag the avcheck.exe as malicious. Okay. And I'm wondering, are we gonna have to do this for a flag? Because if so, I want to do it right now. If not, then we'll just move on. What sig tool output generated? What is the sig tool output to generate MD5 of the avcheck.exe? So let me check to see if we have done that yet, because if so, I'd like to just get these knocked out and not have to wait for them later down the road, but I don't mind although. So let me check to see if it's in samples. This is going to be avcheck.exe. Yeah, okay, so we got avcheck.exe. What is sig tool? Okay, so now we could just use this. I like to just click on the file, click Control or click F2, and then Control A to highlight everything, Control C, and then I have the name now. And then I'm going to run the same commands that we have run, and I'm just going to scroll down here. So I will do this. I will just scroll through this. MD5 see if I can get to the location of where we were running the sig. Probably can't do that. Okay, let me scroll up a little bit here, see how we did it in the previous task here. So it looks like this was the command we used to actually get that to work. So what I can do is just, if I don't want to retype it, just navigate through it, come over here, paste in the name of the av-check.exe and run it. And this is going to point to the C program files, clam AV sig tool, and we're going to get an MD5 hash of the avcheck.exe. So I'm going to grab this hash value, and this is what I'm going to input for that flag, I believe. Oh, actually, it looks like it wants the whole output. So, okay. You want the whole output? I'll get you the whole output. There it is. Use the string tool to list all human readable strings of the AV check binary. What is the flag? All right, all human readable. Okay, so I feel like that's gonna be the next one, but let me create your own database. We did that, right? So strings. Let me just do this. So I'm just gonna type string in here to see where that comes up. And let's see here. I'm just gonna string existing. Oh, string right there. Strings to binary. Use the strings tool. Strings with an S. Okay. Let me do a hint for that one. The flag starts with this. Oh, I see. Okay. Well, that's interesting. Let's not get too far ahead of ourselves. I just obviously wanted that one because we have the skills to do it. Um, Let me scroll up a little bit here, and we'll, I guess, go into the next one, which will be to look at the YARI rules. One of the tools that help in static detection is YARI. YARI is a tool that allows malware engineers to classify and detect malware. YARI uses rule-based detection, so in order to detect new malware, you need to create new rules. ClamAV can also deal with YARI rules to detect malicious files. The rules be the same as in our database in the previous section. To create a rule, you need to examine and analyze the malware. Based on the findings, we write a rule. Let's take avcheck.exe as an example, and write a rule for it. First, let's analyze the file and list all human readable strings in the binary using the strings tool. As a result, we will see all functions, variables, and nonsense strings. But if we are looking closely, we can use some of the unique strings in our rules to detect the file in the future. The AV check uses a program database .pdb, which contains a type of symbolic debugging information of the program during the compiling. Okay, so using strings, AV check.exe, find PDB. Okay, we will use the path in the previous command output as our unique string example in the YARI rules that will create the signature. Could be something else in the world, such as a registry command, etc. If you are not familiar with YARI, then we suggest checking out the YARI theme. The following is a YARI rule that we will use in our detection. Okay, so rule, demo, meta, author, then intro to AV room, description, look at how the YARI rule works with ClamAV, string, and this is a string here, condition A. Let's explain this YARI rule a bit more. The rule starts with rule, then demo rule, which is the name of our rule. ClaimAV uses this name if a rule matches. The metadata section, which is general information, contains the author and description, which the author can fill. The string section contains the string or bytecode that we are looking for. We are using the C program database path in this case. Note that we added an extra slash in that path to escape the special characters so that it does not break the rule. Okay. In the condition section, we specify that if the defined string is found in the string section, then flag the file. Note that YARI rules must be stored in YAR extension files for ClaimAV to deal with it. Let's rescan the C/user stem desktop sample file again using the YARI rule we created. You will find a copy of the YARI rule on the desktop at this location here. All right, so without having to actually do that, I guess we can just run this. So essentially what it's doing, and I'll just kind of jump on top of this pylon, is YARIs can be used for static detection of an I0C indicator compromise in cybersecurity world. And this would be an indicator of compromise if we were to detect this this right here. So it's just going to flag that, and it's something that we can investigate if we were to see this being detected. And indicator compromise, it's kind of like key piece of information that will help you determine if you're actually compromised. It's something that's hard to hide, and so it's kind of like, how can I say this? So let's say, well, let's go ahead and follow along with this, and then I could explain it towards the end. And what I'm going to do is I'm just going to go ahead and just grab the command here that they want us to use. First, I'm going to run this one right here for the string and see what that displays. Okay, right. And when I do that, it shows this right here. All right. And next, I'm going to grab this and I'm going to paste that in. Okay, so that's not exactly what I was expecting, but I think I know why. I think I put the wrong command. So let me grab this here, paste it in again. Now that's the right command. All right, and I'm gonna run this. I have to move my cursor. Okay, and I ran that. Desktop files, demo YAR rules. Oh, okay. So I guess we have to input that in there then. In the desktop files, then demo YAR rules. I thought they had that in there for us, but let's take a look here. Go to desktop, and this is supposed to be in the desktop files. Okay, go on files, make sure it's there. And we have the demo YAR one. There it is there. So that should work. Let me take a look at it. And we can see they've basically just pasted this in there. So that's interesting. Let me close that out and come over here and just make sure I'm actually opening this from the right location. So I can see that they're running this command from the user's them, and that's why it's not working, because I'm just not running the command from the same location. So I'm gonna go cd ... to change directories, cd ... and that's gonna send me back, and now I'm in the correct directory. Now I could navigate to it, but for someone that's new, I kind of just want to kind of make it easier for you. And so I'm just going to right click, just going to put the command in there, and then now it should work. And it's working. So this is great. As a result, AV clam can detect the AV-check.exe binary as malicious based on the URI rules we provided. However, ClaimAV gave a false positive result where it flagged the notes.txt, yep, I see it, as malicious. If we open the notes.txt file, we can see that the file contains the same path we specified in the URI rules. Let's open that up, let's see what that looks like. Samples, notes.txt. Okay, yeah, so it's got the same path, the same indicator that it's looking for. So let's close that out. Let's improve our YAR rules to reduce the false positive results. We will be specifying the file type in our rule. Often, the type of the file can be identified using magic numbers, which are the first 2 bytes of the binary. For example, executable exe always starts with ASCII MZ value, or 4D5A hex. To confirm this, let's use the hexd XD application, which is a freeware hex editor to examine the av.exe binary and see the first 2 bytes. Note that the hxd is already available in the provided VM. Okay, so I'm just going to type hbd. And if you guys don't know, I make these videos late at night. You know, I'm a normal dude. I work 40 hours, sometimes more. And, you know, I get home and I'm really tired. But I'm making this video at 11:14 p.m. Pacific time. So it's nighttime. My wife's asleep. So, you know, I really appreciate if you guys like and subscribe because I'm doing this for myself so I could become better at cybersecurity. And I thought, why not record it and help somebody else out there who may be you know, struggling with something like this. So, and if you didn't watch my video yesterday, you can see me struggling because, you know, we all struggle at some point or another, and you know, it happens. But we're gonna get through this together. And I'm probably gonna split this video. So after I collect this last flag, I'm probably gonna call it quits and do the rest tomorrow. But you know, this is really great. So anyhow, sorry to go off on a tangent. Let's go ahead and open this up. Now I can see here that they've actually provided a path right there. So I typed for hxd. Oh, maybe I didn't type it right. So let me go hxd. There it is. Okay, great. So hxd, and I'm just going to open this. And once I open this, looks like they went to the malware samples, av-check.exe. And so we'll just do the same. So I'll go to open, desktop, malware samples, desktop. They name theirs malware samples, but I just have mine as samples. But okay, we'll just do that. av-check.exe. All right, click open. And we'll see if it gets me anything here. Okay, I'm trying to see this. Ooh, okay. Looks like the screen might be a little off here. Maybe it's just me. Maybe, yeah, no, it's the screen. Let me see if I could get this to, oh no. Options, okay. View, adapt to window width, adapt to Windows width. All right, so that didn't really work. Let me expand it out maybe. All right, okay. So, go to, no, that didn't work. So let me see here. I'm looking for 4D. Maybe if I just scroll down, it's here somewhere. No, that's not it. Right. Checksum, view. It's for text encoding. Checksum. Offset, byte size group, data inspector. Checksum. Let's go data inspector. Maybe it's that one. Search, find, place. Okay. First time I've used this tool, so just bear with me, people. I might have to pause it and then just play around with this a little bit. Okay, had a little bit of trouble with that. I'm trusting that this will work. I'm just gonna go and move that off, and then we'll continue on because they provide the screenshot. Looks pretty good to me. And you know, we see that 4D, 3A, and hex indicating which in ASCII is MZ, which is indicating that this is an executable. So knowing this will help us improve the detection. Let's include this in our YARI rule to flag only executable files that contain the signature string as malicious. The following is an improved YARI rule. Okay, In the new YARI role, we define a unique string cache B equal to MZ as an identifier for the exe file type. We also updated the condition selection, which now includes the following conditions. If the string MZ is found at the 0 location, okay, the file beginning. If the unique string, the path occurs in the binary, okay, this one. If the condition selection, we use the AND operator for both definition in 1 and 2 are found. Then we have a match. You can find the update rule end here. Now that we have our updated YARI rule, we can now try this, and I'm pretty sure you can overwrite the current YARI rule right now as well under files, and you could just overwrite this as well. But we'll just use the one they have, you know. And we'll just go ahead and run this. So most importantly, look at where this is running from, users, and I'll open up my command prompt and see that we are in that location. And now I can go ahead and just run the sample. So if it can detect, and this is more I guess this is more granular YARI rule. So sorry guys. So here it says everything's okay, and so it's only looks like it may be giving us false positive. Yeah, the output shows we improved our YARI rule to reduce the false positive results. That was a simple example of how AV software works. Thus, the AV software vendor work hard to fight against malware and improve their product and database to enhance the performance and accuracy of results. The drawback of the signature-based detection is that the file that we have hashed value if the binary is modified. Therefore, it is easy if someone to bypass the signature detection techniques if they know what AV software is looking for and how to analyze binaries as shown in the later rooms. Okay. Well, this looks better. So we didn't have the we reduced the false positives. So that looks great. And let me take a look at this next task here. Using the signature tool to list all human readable strings of the AV check binaries. What is the flag? Use the string tool. Binaries. Okay, so it looks like what we're doing is we're just running the string. It sounds more complicated than what it really needs to be. String of the AV check binary. Okay. String tool list all human readable strings. AV check binary. And as AV check is that a file? Let me check. Samples. Yeah, it's AV check. Okay. Well, let me scroll up here because we were using the string command a second ago. Here it is. And I'm gonna copy that, and it looks like we ran that from samples. So why don't we just navigate to samples real quick? CD desktop. Unlike how a case doesn't matter, so desktop samples. All right, and I'll do TIR so we can see our samples there. And we'll just paste in this command here, and it's looking for find string, and it's wanting a human readable string. So let me try running it without the bad command line. So, all right, why don't we do this? We'll -- help and see what we get. Oh, this is a sysinternal tool. Oh, so there's definitely something, like you can probably Google this and figure it out. String, and I do want to Google it, but I'm gonna take the hint. Flag starts with find string. Ah, there we go. I knew it. So you do the quotes, THM, and then we'll look for that specific string. And hey guys, we got the flag. There it is, right there. Oh, grab that. E. Oh gosh, grab the flag, please. All right, got it. I got the flag. Okay, good. All right, paste that in there. Yay. Let me take a look at the next one. See how this looks. Which detection method is used to analyze software? Okay, that's not too difficult. And this one, are we gonna have to capture a flag on this one? No, it's just reading. Wow, this is all reading. So you know what? I'm gonna truck through this one. I'm gonna drink some water, and be back in a sec. All right, I'm back, guys. Because this one is a free room and available to anyone. I'm gonna go ahead and post a link to how you can set up your own attack box. That way, if you're new, you can do that. Just because I know people who are new to this may not know how to do that, and I want to get more people on the platform because this is amazing. I wish they had this when I was, trying to get into IT and cybersecurity back in the days. It's very cool to have. So let me open up a notepad real quick. If you don't know, guys, I always put the flags in the description. Pretty unique. It's a niche that I made. Probably the only one I know of that does that. Most people, they'll hide the flags. I don't do that. So I'm gonna just go ahead and put that in the description. And looks like we have one more here. It's not too difficult. And also about test 5, static detection and YARI rules. Now, if you don't think you're gonna use this in cybersecurity, think otherwise, because YARI rules are becoming extremely popular. And if you guys don't know, I actually work cybersecurity. I've been working for a while in cybersecurity. And, I climbed my way up to the top. I didn't start off in cybersecurity, okay? But, one thing I've noticed in cybersecurity is that, um, you know, we're using YARI rules to help identify indicators of compromise, okay? And this is extremely important because if we think about this, it may take a while for a vulnerability like a 0-day to become a CVE, right? Or for a plugin to be released for a CVE. So in that meantime, how are we supposed to detect this stuff? Well, the antivirus, it's great that they create hashes and they use this static detection, but it's just not good enough. Like we need the ability to detect malware at its core. And the way you're going to detect is those core files of the malware. In a lot of situations, they don't change, right? Unless, of course, the adversaries they're being more, they're packing them and they're trying to evade detection. Okay, but these YARI signatures are doing a really great job at finding those core files, like we did in this example, and flagging it and letting us know that we should look into this further. So YARI rules, they're becoming very popular. And if you're someone who works with like Nessus or in the cybersecurity space, I would highly recommend you take notes on this because this is something that I think moving forward we're going to see a lot more of. Okay, so there's my spill. All right, let's go ahead and move on to next task here. Other detection techniques. The concept of static detection is relatively simple. In this section, we'll discuss the different types of detection techniques. Dynamic detection. The dynamic detection approach is advanced and more complicated than static detection. Dynamic detection is focused more on checking files at runtime using different methods. The following diagram shows the dynamic detection scanning flow. So file formats, we have different file formats, exe, DLLs, docs, PDFs, going through a dynamic engine, Windows API monitoring sandbox, and if it detects something as it runs those files, I'm guessing it's the dynamic portion, because it's actually running them to see what they do. And if it detects something malicious, it will say, hey, this is malicious. If not, it'll say, this is malicious. Okay. The first method is by monitoring the Windows API. The detection engine inspects the Windows application calls and monitors Windows APIs using the Windows hooks. And just so you guys can see this better, what I'm doing is I'm going to go ahead and just kind of minimize this a little bit so we can just focus on the reading portion now because we're done with the lab, I believe. Okay, so where was I? Reading. Okay, so another method of dynamic detection is sandboxing. A sandbox is a virtualized environment used to run malicious files separately from the host computer. This is usually done in an isolated environment, and the primary goal is to analyze how the malicious files act in the system. Once the malicious software is confirmed, a unique signature and rule can be created based on the characteristics of the binary. Finally, a new update will push into the cloud database for future use. This type of detection also has drawbacks because it requires executing and running malicious software for a limited time in a virtual environment to protect the system resources. As with other detection techniques, dynamic detection can be bypassed. Malware developers implement their software to not work within the virtual or simulated environment to avoid dynamic analysis. For example, they check if the system spawns a real process of executing the software before running malicious activities and lets the software wait some time before executing. For more information about sandbox evasion, let's suggest checking the theme room sandbox evasion. I think that's in the next room that we're going to be going to. So heuristics and behavior detection. So before we go into heuristics and detection and behavior detection, let's go back to this dynamic detection. So dynamic detection is really like a sandbox. It's really all it is. In a sandbox, it's essentially running this program within a enclosed environment. Okay, and the interesting part about this, and maybe I should make a video on it, is that Windows actually comes with its own virtual sandbox. You can look it up yourself. Windows comes with its own virtual sandbox where you can actually run software within that virtual sandbox, and then afterwards you can close it, and you'll no longer. It essentially just destroys that little Windows session you had. Okay, pretty cool stuff. I'll probably make a video about it in the future. But you know, dynamic detection is really great, especially when static AV detection doesn't cut it, right? Simply knowing a hash won't cut it. You need to know more than that, you know, especially with these very complex malware and ransomware that we're seeing these days. So heuristic behavior detection. Heuristic behavior detection have been essential in today's modern AV products. Modern AV software relies on this type of detection to detect malicious software. The heuristic analysis uses various techniques, including static and dynamic heuristic methods. First, heuristic analysis is the process of decompiling, if possible, and extracting the source code of the malicious software. Then the extracted source code is compared to other well-known virus source codes. This source code are previously known and predefined in a heuristic database. If the match meets or exceeds a threshold percentage, the code is flagged as malicious. Dynamic heuristic analysis is based on predefined behavioral rules. Security researchers analyze suspicious software in isolated, secured environments based on their findings. They flag the software as malicious. Then behavior rules are created to match the software's malicious activities with the target machine. The following are examples of behavior rules. If a process tries to interact with the alsas.exe process that contain the user's NTLM hash, the Kerberos ticket, and more if the process opens a listening port and waits to receive commands from a command and control server. The following diagram shows the heuristics behavior detection scanning flow. So these files, if they're doing some sketchy stuff, then it will flag it as malicious. If not, then it's good. All right, summing up detection methods. Let's summarize how modern AV software works as one unit, including all the components, and combines various features and detection techniques to implement its AV engine. The following is an example of components of antivirus engines. Here is how the antivirus detection works. So foobar.zip, foobar.exe, And we'll just read through this. In this diagram, you can see a suspicious foobar.zip. The file is passed to the AV software to be scanned. AV software recognizes that it's a compressed file zip since the software supports zip files. It applies an unarchived feature to extract the file foobar.exe. So extracts foobar.exe. Next, it identifies the file type to know which module to use with, and then performing a PE parser operation to pull the binary information and other characteristic features. So it's pulling what type of file it is, putting in the PE parser. Next, it checks whether the file is packed. If so, it unpacks the code. Finally, it passes the collected information and the binary to the AV engine, where it tries to detect if it is malicious and gives us the results. Okay, unpacks it, checks to see if it's malicious. Which detection method is used to analyze malicious software inside virtual environments? Is used to analyze malicious software in virtualized environments. I would say that's the sandboxing one, which is dynamic detection, which I mentioned earlier. Is like Windows has one by default. Definitely, I played around with it a little bit, and think about it this way: if you have a sandbox, right, and then you spin up or you start up Wireshark. Now, not just are you confining that malicious malware to that virtual machine, but now you're watching all communication between it and the outside world. Very cool stuff, especially if you think you might have malware, you essentially just made your own sandbox and you're able to analyze the traffic. So that's just something I wanted to mention as well. Wow, I really like this room. This is great stuff because I don't know everything and I've learned a few things here. So, task 7, AV testing and fingerprinting. And let me just scroll down a little bit here because it's getting late, guys. It's 11:38 now. All right. All right. So I'm gonna speed read this one. So sorry if I stumble on my words. So AV testing and fingerprinting. AV vendors. Many AV vendors in the market mainly focus on implementing a security product for home or enterprise users. Modern AV software has improved and now combines antivirus capabilities with other security features such as firewalls, encryption, anti-spam, EDR, vulnerability scanning, VPN, etc. It is important to note that it is hard to recommend which AV software is best. It all comes down to the user's preference and experience. Nowadays, AV vendors focus on business security in addition to end-user security. We suggest checking the AV comparison website for more details on enterprise AV vendors. AV testing environments. AV testing environments are a great place to check suspicious or malicious files. You can upload files to get them scanned against various AV software vendors. Moreover, platforms such as VirusTotals use various techniques and provide results within seconds. As red teamers or pen testers, we must test a payload against the most well-known AV applications to check the effectiveness of the bypass technique. VirusTotal. VirusTotal is a well-known web-based scanning platform for checking suspicious files. It allows users to upload files to be scanned with over 70 antivirus detection engines. VirusTotal passes the uploaded file to the VirusTotal engine to be checked, returns results, and reports whether it's malicious or not. Many checks are applied, including checks for blacklisted URLs and services, signatures, binary analysis, behavior analysis, as well as checking for API calls. In addition, the binary will run and check in a simulated and isolated environment for better results. For more information and to check other features, you may visit VirusTotal website. VirusTotal alternatives. Important note, VirusTotal is a handy scanning platform with great features, but it has a shared policy. All scan results will be passed and shared with antivirus vendors to improve their products and update their database for known malware. As red teamers, this will be burn a dropper or payload you use in engagement. Thus, alternative solutions are available for testing against various security product vendors, and most importantly, advantage is that they do not have a shared policy. However, There are other limitations. We will have a limited number of files to scan per day. Otherwise, a subscription is needed for unlimited testing. For those reasons, we recommend you only test your malware on sites that do not share information such as anti-ScanMe, 6 free scans a day, virus scan, malware scan. Okay. Fingerprinting AV software. As reteamers, we do not know what AV software is in place once we gain initial access to a target machine. Therefore, it's important to find and identify what host-based security products are installed, including AV software. AV fingerprinting is an essential process to determine which AV vendor is present. Knowing which AV software is installed is also quite helpful in creating the same environment to test bypass techniques. This section introduces different ways to look and identify antivirus software based on static artifacts, including service name, process names, domain names, registry keys, and file systems. The following table contains well-known and commonly used AV software. Antivirus name, Microsoft vendors, Trend Micros, and then you can read through these lists as well. These are well-known. I've heard about a few of these. All right, Sharp EDRC checker. One way to fingerprint AV is by using a public tool such as Sharp EDR checker is written in C# and performs various checks on target machines, including checks for AV software like running process files, metadata, loaded DLL files, registry keys, service, directory, and files. We have pre-downloaded the Sharp EDR checker from the GitHub repo so that you can use it in the activated VM. Now we need to compile the project, and we have already created a shortcut to the project on the desktop, Sharp ED checker. To do so, double click it and open it in Microsoft Visual Studios. Now that we have our project ready, we will need to compile it as shown in the following screenshot. Okay. Once compiled, you'll find a path of the compiled version in the output section as highlighted in step 3. We also added a copy of the compiled version in the user desktop files directory. Now let's try and run it and see what the results are. Okay. As a result, the Windows Defender is found based on the folders and services. Note that this program may be flagged by AV software as malicious since it does various checks and API calls. All right, C# fingerprint checks. Another way to emulate AV software is by coding your own program. We have prepared a C# program in the provided Windows 10 Pro VM, so we can do some hands-on experiments. You can find the project icon on this desktop and double-click using the Microsoft Visual Studios 2022. Follow C# code is straightforward. Its primary goal is to determine whether the AV software is installed based on a predefined list of well-known AV applications. Okay, great. So create some C# code using systems, using system management. So that's required if you're going to interact with any of the Windows variables here. Internal class, so it's internal class static void main. That's all required. Or console write line. So this is going to prompt antivirus check is running, string check, and it's checking for these exes. Searcher, Win32 processes, checking the processes, and it's got like a statement there. Okay, so let's explain the code a bit more. We have a predefined list of well-known AV applications and the AV check array within our code, which is taken from the previous section. So this is the array there where we discussed fingerprinting AV software table above. Then we use the Windows management instruction command line, wmic query, select all from the Windows 32 processes to list all currently running processes in the target machine and store them in the process list. So then we're storing them in this process list here. Okay, variable. Next we go through the currently installed processes and compare if they exist in the predefined array. Okay, for each process in the process list, it's checking to see if they exist. If a match is found, then the AV software is installed. The C# program utilizes WMIC objects to list the current running processes, which may be monitored by AV software. AV software is poorly implemented to monitor the WMIC queries or Windows APIs. It causes false positive results in the scanning of C# programs. Let's compile an x86 version of this program, upload it to VirusTotal's website, and check the results. To compile the C# program in the Microsoft Visual Studio 2022, you just select Build from the bar menu, Build Solution, then you just go about compiling that. So if we upload the AV checker program to VirusTotal and check the results, surprisingly, VirusTotal shows that 2 AV vendors, MaxSecure and SecureAge APX, flagged our program as malicious, probably because the WMIC. Thus, this is a false positive result where it is incorrectly identified a file as malicious where it is not. One of the possible reasons is that these AV vendor softwares using machine learning classifiers or role-based detection methods is poorly implemented. For more details about the actual submission reports, see here. There are 4 main sections: detection, details, behavior, community. If we check the behavioral section, we can see all of the Windows API registry keys, modules, and WMIC queries. All right, and you can see those queries that are being run in the detection section. There is a Sigma rule that if the system events during execution matches sandbox environment, consider the malicious file. This result is likely based on the rules of VirusTotal flagging our program because of the process ghosting techniques as shown in the following screenshot. Right, one match for execution of suspicious file type execution. Check whether the image specified in the process creating an event doesn't refer to the exe file caused by process ghosting or other orthodox methods to start processes. All right, great. Now let's recompile the C# program using an x84 CPU and check if the engines act differently. In our submission attempts, 3 antivirus vendors are listed there, flagged files malicious. For more details. Interesting. If you're trying to submit a file to VirusTotal, it may give you a different result. Keep in mind that VirusTotal shares submission reports in the antivirus vendors to improve their AV detection engines, including false positive results, which may not be a good thing. And I guess I'll just go for the vendors with a good reputation, and not these vendors I have heard of. For C# AV fingerprinting, try rewriting the code in a different language, such as Python, and check whether VirusTotal flags it as malicious. Read above. This is really cool, guys, and I want to get my hands a little dirty here with this. So let me put in my password, and besides the fact it's late and I'm probably gonna fall asleep halfway through this. Now I'm just playing. I'm gonna click to complete these, of course, because why not? And cool thing is that Visual Studio lets you compile your programs so that you can run them. So it takes that interpreted code, interpreted C#, turns it into machine code that your CPU can understand, and it's able to run your program as an executable, essentially. So it looks like we'll just do one of these. Okay, so we'll go to the Sharp EDR checker, which apparently they've put on the desktop. I'm going to check to see if, oh, here it is. I'm going to open it up. And if you didn't know, Visual Studio has a community edition. So if you don't want to spend any money, you can sign up for the community edition, and it's free. So highly recommend you look into that. There's another reason why you should watch my videos, because I've got a bunch of tips. Okay, I've got a ton of IT certifications, degrees, and all that stuff. So I have a lot of knowledge. Be ready, buckle in. I'll give you a lot of knowledge. All right, so build It looks like they have the program here. So, or actually, this is AV check. So this is the program they made in C#, right? So this is the one that they use. They said had an array, and it checks the current process list against, the array. Yeah, cool. I'm not really interested in that one. I'm more interested in this sharp EDR checker. So the sharp EDR checker is located up here. So I'm just going to open that up. Wow, this is Visual Studios 2022, huh? That's cool. All right, we'll wait for this to open. Oof, it's taking a minute. There it is. Hopefully it doesn't take a minute to build, Okay. Well, while that's loading, I guess. Yeah, just wait. Hey guys, be ready. I'm gonna come out with a video, probably this month, maybe next month, for Mimikatz. And if you guys have been tracking, Mimikatz is like a really great tool to use. It's very hard to find because most browsers will block it, but I'm gonna provide it to you guys. Yeah, and it's gonna be great. I'm gonna show you how to use it in everything. Um, so I look forward to that. Another reason to like and subscribe because I'm always making new content. So, all right, this is kind of loading slowly. It's a VM, what do you expect? We should give this a sec here. So, I'm just gonna click build solution. It's already ready to go, I think. And it says project is loading and ready to use. Okay, let's see if it's building it. Come on, build it. Okay, it's loading. Build starting. Did it finish it? Still loading? All right, let me pause it and see if it's finished. All right, I don't know if it finished or not. It looks like it's kind of loading. All right, let's just navigate to it, right? Because they've provided us the location of it. It's in the desktop files, so I'm just gonna go there. Oh, looks like it might be finished. Oh, okay. I think he wants me to create an account or something. Succeeded. Okay, never mind. It's finished. Looks like it's in this location here. So if you want to see where it's at, we can just copy that location. Come over here. Actually, for the Mimikatz one, like I mentioned earlier, the only way of getting it is to compile it. But it's hard to compile it because you can't compile it on Windows because it'll flag it as malware. So let's just say I have it, okay, and it'll work on Kali, promise. All right. So let me move over here, and it'll be used for educational purposes only. That's it. Okay, so I'm gonna change directory to this location, or actually just run it. Just put that file path, just run it, because it's an exe. All right, cool. It's running now. All right, it's doing its thing. It's checking for malicious files. Too bad. Too bad this is a Windows thing, because uh yeah. Okay, that's pretty cool. And it's an EDR. Wow, that's awesome. I might download that. And then you have this one right here, which again, you could compile it. I wonder if they compiled it for you. Oh no, well, we're just using it to upload to VirusTotal. So Not too interested in that, to be honest with you. What I'm probably gonna do is I'm probably gonna copy all these notes. Copy all this and put it in my OneNote, so I have it for reference in case I ever want to play around with something like this. Conclusion. Recap. In this room, we covered antivirus software and its detection approaches. As a red teamer, it's important to know how AV software works and detect malicious applications, be able to implement bypass techniques. We also discussed the static detection techniques in detail and showcase how Clam AV, an open source antivirus detection malicious file using static analysis. Additionally, we showed how to create your own database and use YARI rules to detect malicious files that are not detected by official databases. Once we obtain access to a target, it's essential to enumerate the target machine before performing further actions such as privileged escalation or lateral movement. The reason is not to trigger an alert for suspicious activity, which may cause losing access to the target machine. Thus, we introduce two methods to practice AV fingerprinting using public and private tools. Congrats on completing the room. Yay, confetti! I'm always gonna do this towards I'm always gonna do this at the end, so get used to it. So yeah, that's it, guys. Really enjoyed it. It's gonna be 12. Boy, I need to get some sleep. All right. All right, guys. Hope you enjoy this. Please like and subscribe. I'll say it again. Have a good one. Danny out.